Hello, welcome back to our channel. I hope all they have written nicely that board of intermediate exams, and now you should focus on the crash course of the physics. You can able to do the competitive exams. It may be Eamcet or it may be NEET or it may be that is the JEE Mains. Already I have given the program like day 1, day 2, day 3 like that, one first year topic and one second year topic. I hope it's very useful for the revision program of these competitive exams. Anyway, this is the part 3 from the Rayoptics. Here the first thing is the refractive index of the material of the prism. What is the prism? It is having the two refracting surfaces. See, prism, you are having this one is in lab also. This is the prism. It has two refracting surfaces. You know that already what is the refraction when light falls on the surface. First surface. Here this is the rarer medium. This is made with glass. This is the denser medium. Then this is the normal to the surface. In lab also you are having. Then light bending towards the normal. This is the angle of refraction R1 and this is the angle of incidence I1. Then what happens here? Once again the light ray is coming from denser to rarer medium. This is the normal to the AC phase. Then it is bending away from this normal like that. Okay. This is the angle of emergence I2 and this is the angle of refraction from denser medium to rarer medium. This is the I2. Then one more key role is here, and here angle of prism. Angle of prism is A equals to R1 plus R2. If R1 equals to R2 equals to, we should consider R, then A equals to 2R. From this R equals to A by 2. It's very important. When you know the angle of refraction only, we can able to find out the refractive index of the material of the prism. Then what is the angle of deviation? You extend the incident ray. If there is no prism, the incident ray is moving like this. Then you extend the emergent ray back where these two are coincide, and the angle between incident ray and emergent ray is called the angle of deviation. So angle of deviation is I1 plus I2. I1 plus I2. This is the angle of incidence minus angle of the prism. This is the angle of deviation. From this I1 plus I2 equals to delta plus A. Then if I1 equals to I2 equals to I, then you can get it 2I equals to A plus delta. Then I equals to A plus delta by 2. Don't confuse, this is the angle of refraction and this is the angle of incidence. When we know the angle of incidence and angle of refraction, we can able to find out the refractive index of the material of the prism. Many people are thinking refractive index of the prism. No. For that, which material we are using? For glass, mostly we are using the glass. For that, we can able to find out the refractive index. Whatever the material, with the help of this formula, we can able to find out the refractive index of the material of the prism. What is that? Mu equals to, from this Snell's law, sin I by sin R. Here sin I is the A plus delta by 2. Then sin R is the sin A by 2. With the help of this, we can find out the refractive index of the material of the prism. We do one problem based on this. Look here. If A equals to 60 degrees, then this delta equals to, we can take it 30 degrees. Then how to find out the refractive index of the prism? Mu equals to sin A plus delta. 90 by 2 is the 45 degrees. And this is angle of the prism is 60 by 2 is the 30. This is the sin 30 degrees. So this is 1 by root 2. This is 1 by 2. Then after simplification, this is the root 2. Mu value how much? 1.414. You know that there is no unit for the prism. Like that, for any angle, with the help of the logarithm book also, we can find out the refractive index of the material of the prism when we know the angle of incidence and when you know the angle of the refraction. And not only this one, here one special condition is there. If the prism is having the small angle, at that time no need of taking the sine terms. So for small angled prisms, For small angled prism, we can take it mu equals to simply a plus delta by 2 divided by a by 2. This one cancel. You are getting a plus delta by a. The problem is like this. If the angle of the prism is 4 degrees, that angle you can observe here, that angle is very small. In this case, suppose the given data is a equals to 4 degrees, then delta equals to 2 degrees. Find the refractive index of the material of the prism. So in this case, how to find out? Direct you can take it a plus delta by a. 4 plus 2, 6. 6 by that angle of the prism is the 2. This is the 1.5. So like that we can find out the refractive index, and you read that question properly. Is it small angled prism they mentioned? Immediately you can use this one. With the help of this, not only refractive index, when we know the refractive index, we can able to find out the angle of the prism, angle of the deviation and refractive index based on the given data. Like that we are going to discuss about what is the dispersion. Dispersion we know in lower classes only. Splitting of light into its constituent colors, that is called the dispersion. When light falls on the prism, this is the prism, you know that light is having 7 constituent colors. Whenever light falls on this, then what happens? It splits into 7 colors with GR, like that. Which color is having more deviation and which color is having less deviation? So this is the with GR. Always you remember that refractive index of violet is greater than refractive index of the red, and deviation of violet is greater than deviation of the red. So refractive index is inversely proportional to wavelength. So wavelength of red color is more than wavelength of the violet color. From this we can find out the dispersive power and angular dispersion also. What is the angular dispersion? We are taking any two colors and we can find out the difference, and we can take the border colors also, we can find out the angular dispersion. What is the angular dispersion? Look here, angular dispersion, theta equals to delta V minus delta R. Delta V minus delta R. When you know the deviations directly, we can find it like this. Suppose this is 4 degrees and this is 2 degrees. We can say that 4 minus 2, 2 degrees. Just I am giving the example here. Then from this expression, you know that mu equals to a plus delta by a. In terms of angle of refractive index of prism and angle also we can find out. See here, delta equals to what we are writing, a into mu minus 1. Then it should be right, instead of delta V, deviation of the violet color, a into mu V minus 1 minus a into mu R minus 1. So after simplification, a is the common, mu V minus 1 minus mu R plus 1. See, theta equals to a into mu V minus mu R. We got two formulas, same angular dispersion. This is in terms of angle of deviation and this is in terms of refractive index of the different colors and based on the angle of prism. After this we can focus on the dispersive power. What is the dispersive power? It is represented by omega. It is the ratio of angular dispersion to the mean dispersion is called the dispersive power. Already you know that angular dispersion is a delta V minus delta R. Mean dispersion is the mean of these two, delta V plus delta R by 2. Mean is nothing but yellow color. So omega equals to delta V minus delta R by delta Y also we can able to write it. So this is the dispersive power and this is the angular dispersion in terms of angle of the prism and refractive index. This is the angular dispersion in terms of deviation of the colors, and this is about the normals for small angled prism, how to find out the angle of deviation. This is the formulas based on this. Is the refraction from the spherical surface. You know that there are two types of lenses. In this we can observe that refraction from the lenses. There are two types of lenses. One is the convex lens, that is called the converging lens also. Then after reflection all rays are focusing at a single point, converging. Diverging means those are looking diverging from that point, that is the diverging lens. Concave lenses are nothing but the diverging lenses. So whatever the lenses, these are very useful in our daily life also. Some people are suffering from the myopia and hypermetropia. What is the myopia? Short sight. So all the light rays are coming and focused in front of that retina. For that, avoiding that, we are using the concave lenses, and for hypermetropia also we can rectify with the help of the lenses. Then here refraction at spherical surface. This is the refraction, this is the spherical surface, this is the object distance u, and this is the image distance v from the, this is the image, and this is the image distance is represented by v. Radius of curvature is how much? From the optic center it is the r. So based on this we are making one formula here. mu2 is the refractive index of that material of that lens, and mu1 is the refractive index of that surrounding material. If it is in air, that is the air. If it is in liquid or it is in water, you can take mu1 is that one. So after that RHS side you are getting difference of that refractive index by radius of the curvature. And already you know that lens formula is 1 by f equals to 1 by v minus 1 by u. In terms of refractive index also and radius of curvature, we can express this formula 1 by f equals to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Here r1 and r2, suppose we are taking, this is the concave lens. This part, the radius of curvature is the r1 and this is the r2, we can take it. This is the biconvex lens. This is having two radii of curvature. If we are both are equal, this is the equiconvex lens. This is the equiconvex lens. Here r1 equals to r2. And plano-convex lens. This is the r and this is the infinity. Like that there are different types of convex lenses. Then this is the lens maker's formula, very important. 1 by f equals to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Here mu2 is the refractive index of second medium, refractive index of the first medium. We can write like this also. Suppose the convex lens we are placing into the air. At that time you should write it 1 by f equals to 1 mu2 by, I am taking 1 by refractive index of air is 1 minus 1 by r1 plus 1 by r2. For convex lens you remember that r1 is positive and r1 is negative. That's why you can get it here minus into minus plus you are getting. Suppose same thing we are placing in liquid. At that time refractive index, focal length of that liquid, mu2 by, suppose this is the liquid means mu L minus 1 by r1 minus 1 by r2. Means entire lens we are placing into the, dip into the water. At that time we can get the ratio also. FL by F equals to, this is the mu2, this is the air means we can take air also, by mu second medium is nothing but glass. This is the glass because lens is making with the glass. Liquid minus 1. This one cancel because both are having the same radii of curvature and same thing it will cancel. Like that we can get this for convex lenses for different radii of curvature. And here there are different cases for equiconvex lens. How to get the focal length formula? 1 by f equals to, we can get it mu minus 1 into 1 by r plus 1 by r. We are getting 2 by r. So mu minus 1 into 2 by r. This is for the equiconvex lens. Like that for plano-convex lens, r2 is how much? It is the infinity. Then how to write the focal length formula? 1 by f equals to mu minus 1 into by r. This is for plano-convex and this is the equiconvex lens, like that. Then like that there are different cases for concave also. This is the concave lens. This is the R1 and this is the R2. In this case we can write it 1 by f equals to same mu minus 1 into, here R1, R2 is the positive for convex lens and this is called the diverging lens also. Then R1 is the negative. That's why we are getting here minus 1 by R1 minus 1 by R2. So it should be right 1 by f equals to minus mu minus 1 into 1 by R1 plus R2. See if those are, if R1 equals to R2, at that time how to write this one, this expression same, we are getting minus mu minus 1 into 2 by R like that. So this is about the concave lens and that is about the convex lens. Depends on the focal length, refractive indexes, we can do the problems. The next thing is there are different cases. Suppose we are taking two convex lenses are separated by a distance d. All these formulas are just we are revising for competitive exams. Only 2 months and 1.5 months left for competitive exams. Just you can go through the formulas and practice the problems. We are taking two convex lenses. This is the f1 and this is the f2 focal length. Both are separated by a distance of d. In this case, what is the resultant focal length? 1 by f equals to, we can write it 1 by f1 plus 1 by f2 minus d by f1, f2 we can take it. Suppose in this case there is no gap, we can arrange like this. Here 1 by f equals to, simply we can take it 1 by f1 plus 1 by f2. And one more very important concept is reciprocal of focal length is called the power. See, power equals to 1 by f. If it is in centimeters, we can write it 100 by f. This unit is the diopter or meter inverse. For this, how to write the power expression? P equals to P1 plus P2 minus D into P1 P2. For this one, we can write it P equals to P1 plus P2. So whenever we know the focal length, reciprocal of focal length is nothing but power of that one. Now we are going to discuss about optical instruments. This we can able to see the small objects also with the help of the microscope. First they discovered that simple microscope, then they are increasing technology like that. Then finally now we can able to see that electron microscope also available. So we can able to see the electron through that microscope. So in this case, first thing is the simple microscope. Here we are using the one convex lens. This is the object and this is the image. Image we can observe at 2 points. You can you know that for normal human being that near point where we should observe minimum distance to maintain that, to look that one is the 25 centimeters, that is called the near point of the eye. Then far point is the infinity. So at near point magnification is 1 plus d by f. D is the near point and f is the focal length of this convex lens, and it is increasing the magnifying power. That's why small micro thing also we can able to see that big like that. So and far point it is at infinity, m equals to d by n. Like that compound microscope. Here we are using the two convex lenses. One is the objective lens, another one is the eye lens. The lens which is nearer to the eye, that is called the eye lens. This focal length is more comparing with this one. Here when the rays are coming like this, here we can observe that f0, and this is acting as a object of this one, then we can get the image like that. Anyway, here final image at infinity and final image at near point, the formula is minus V0 by U0. V0 is the image of that object and U0 is the object distance. 1 plus d by Fe. Fe is the focal length of the eye lens. You must by heart all these formulas. Then final image is at infinity. So you can get it m equals to minus V0 by U0 d by Fe. In some cases, length of this one, the distance between these two lenses is how much? V0 plus UE. Approximately LD by, in terms of F0 and Fe and L and D also you can able to find out the magnification at infinity. This is about the compound microscope. Then last one is the telescope. It is increasing the visible angle. Then far objects also we can able to see that clearly. That is the use of the telescope. And here also we are using the two convex lenses, but in this case objective lens is more, focal length is more comparing with the eye lens. This is the magnification at near point, and this is the magnification at far point, and this is about the distance between the two lenses. Thank you everyone. There are three parts in that ray optics. First part belongs to reflection, and second part belongs to refraction, and third one is the refraction and optical instruments. So you divide all these parts and you have to prepare, and you must remember all these formulas. First you know the concept, then you remember that formulas, then you have to do the problems, then you can go to the exam. So please share these all videos to your friends also, then you can share the knowledge, and these are very useful for them. And better if subscribers are more, I will teach you more and I am getting the more instead. So please subscribe my channel. If you like these videos, like and share with to your friends. Thank you everyone.